Lessons 8.3 and 8.4 combined are about the volume of cones and spheres. And in both of these cases, we're given a formula on the reference sheet. So for cone, the volume equals 1/3 pi r squared times the height. And for the sphere, the volume equals 4/3 pi r cubed. Notice that both of these are using pi and radius, which tells you we're dealing with circles. And of course, cones and spheres are both circular three-dimensional figures. Also notice this. For the cone, it is 1/3 times pi r squared times the height. That's the volume of a cylinder. And so if you take a cylinder and multiply by 1/3, or that's the same as dividing by 3, then you get the volume of a cone that has the same radius and the same height. So that's helpful information to know and to refer to as well. But we're given these formulas on your reference sheet, so make sure you keep that handy and refer to it often. Find each volume to the nearest tenth. Use 3.14 for pi. Part A, we're given a cone. It has a radius of 1 foot and a height of 3 feet. So we begin with our formula. Plug in the values that you know. And notice that there is an exponent, so we're going to go ahead and simplify that, but 1 squared is still just 1. Then multiply, and we get that the volume is equal to 3.14, which rounds to 3.1, and we're dealing with cubic feet since we're dealing with volume. For B part, we're given a basketball with a diameter of 9.4 inches. We could start by drawing a picture of this. It's not always necessary, but it could be helpful. Notice this basketball looks like a circle, and then it's got some dashed lines showing the curves around the front and back and going around the basketball. And it has a diameter of 9.4 inches. We do need to remember the fact that a diameter goes all the way across a circle. It does not go halfway like a radius does. So it gives you that the diameter is 9.4 inches, but that is not the radius. So we do need to remember that radius is half of the diameter, or halfway across. So in this case, the radius would be half of 9.4, which is 4.7 inches. And so now we're ready to begin by plugging into our formula. So we write our formula down, plug in the values that were given, and go ahead and simplify the exponent. Notice that when I simplified the exponent, I went out as many decimal places as my calculator gave. It went out 3 decimal places. Be careful not to round in the middle of a problem. Now, if it had given you a decimal that kept on going, then it's fine to round a couple decimal places beyond what you're rounding at the end. But let's be careful not to round prematurely. And so we get 434.67, and it keeps on going. So when we round, that comes out to 434.7 cubic inches. So that's about the volume of a basketball. Part C, a hemisphere on top of a cone with a radius of 5 centimeters and a cone height of 16 centimeters. So I might start this by drawing a picture, and it kind of gives the idea of an ice cream cone filled with ice cream. And so I've drawn this hemisphere on top of a cone, and we want to find the volume of this total composite figure. So we're going to find the volume of the hemisphere, then the volume of the cone. Now a hemisphere, if you look at the prefix hemi, sounds like semi, and it just means it's going to be half of the sphere. So I'm going to multiply half times the volume of sphere, which is 4/3 pi r cubed. And then we're going to add the volume of the cone. The formula is volume equals 1/3 pi r squared times height. And we'll just start plugging into these. For the hemisphere, 1/2 times 4/3 does simplify to 2/3, times pi, which is 3.14, times the radius, which is 5, cubed. And then for the cone, 1/3 times 3.14 times the radius, 5 squared, times the height, 16. And now we can go through and simplify the exponents. And so for the hemisphere, 2/3 times 3.14 times 125. And for the cone, 1/3 times 3.14 times 25 times 16. And all we're doing is simplifying these. And so then, for the hemisphere, we get about 261.6 repeating. I'll go ahead and round out to about 0.67. And then for the cone, we get 418.6 repeating, so I'll go ahead and round that out to 0.67. And then we just add these, and to the nearest tenth, we get about 680.3 cubic centimeters. And we have found the volume of this composite figure.